So I'm thinking, let's see how today goes. Well, let's not talk about that right now. Let's see how today goes as far as what Thursday looks like. We're definitely wrapping down. I mean, we're definitely, I plan on doing one more quiz in class today. A couple people had emailed me, I guess I didn't get yours yet, Amaya, but I definitely wanted to get one more in, and I think today will be it. It's revisiting the brakes on the bike with a third set. And I got the data for us to play with in class. And that's pretty much all we got to do. I mean, in this class, as far as that goes. I know a bunch of you guys are done after this class, which is why I like the last exam, the one that you guys are turning next week. Because it focuses less on just blind regurgitation of which tests to do, and focuses more on the interpretation of what the results from tests are, which honestly is what most of you guys are going to be doing in the world anyway. I mean, in all honesty. For example, Thursday, last week, M&M's. I was surprised. Why was I so surprised on Thursday? I sat here like an idiot with my mouth open. You guys were like, what are you so surprised about? Veronica, what happened?
Because it actually matched their data.
So I had to write a brand new letter. I had to write a brand new letter to Mars. If you've been by my office, you've seen all the letters I've written to Mars once every 3 months that says, hey, guess what? Your numbers are wrong. Hey, guess what? Your numbers are wrong. Hey, guess what? Your numbers are wrong. So, last May 30th, to my M&M's, Attention Customer Service, to whom may concern, hello and greetings from Bend, Oregon. This is your tri-yearly letter to assist you in the quality control of your colors of your milk chocolate M&M's candies. You'll notice a different focus in this letter, however, because of course they read my other ones. You see, for the first time in history, we're not writing to tell you that your milk chocolate color percentages are in error. In fact, we're writing to tell you that percentages you claim actually showed up in class. Took a little picture, a screenshot from the Excel. That's what we got. That's what they said we should have got. That makes us happy. You might notice that the percentages don't perfectly match, because they don't. I mean, if you look at the 21, we got 21% orange. It was actually 20, should have been 20. We got 15% green, should have been 16. We got 13% yellow, should have been 14%. Why did I tell them it's okay? See, make me very proud right now. Because it's within a margin of error. Because it's within a margin of error. And I explain that to them. I say, in inferential stat, we accept values within a margin of error, and we're close enough by margin of error standards, and I put chi-squared equals 2.23, p equals 0.82, and I said, if you want an explanation, go back to our previous letters where we explained very, very carefully, which I'm sure they still have on file in the watch list. So, bravo! It's clear that our letters have been helpful to you, and you've adjusted your machinery to match the percentages, albeit a more expensive solution than ours. Give us more candy, let us derive the percentages you are achieving, and then advertise them. I always offer that every term. Because they always screw up. And I say, send us more candy, and we'll take whatever you've got, build a model around it, and then you can advertise this on your website. It's much easier than trying to fix your machinery, but they decided to go ahead and fix the machinery. We're proud to have been part of the solution. Be well. Sincerely, the Tuesday, Thursday, Math 244, and you guys, if you don't mind, sign this at break. And then I put a PS, but wait just a minute. And that's page 1. Over here, have you guys signed that at some point? It's more official, I think, if you guys sign it. Why the sudden switch? See, that's what was blowing my mind the whole time. Why the sudden switch? I mean, for years now, we've been seeing the same results term after term. Your percentages never agree, like ever. Why now? So I took a picture of the boxes. You might remember a little discussion we had at the end of the day, because I had 2 boxes. One was left over from the previous term, and one was brand new. But I bought them both at the same time at Costco. You remember the big deal about the 2 boxes that I bought at the same time? What happened last term? They were off, like they always are. So it seems strange that one box will be off and one box will be on. That seems strange to me. So anyway, there's something else, and I explained about the lot codes being the same, and I give them last term's statistics, which is the chi-square was 223, and the p-value was essentially 0, 4 times 10 to the negative 46. They have that in our last letter, which I'm sure they have a quick recall of. The bottom one did. We can think of 4 possible explanations. I say we. Hope you didn't mind if we spoke for you over the weekend. Number 1, last term we got a false positive, this term we got a true negative. Number 2, last term we got a false positive, this term we got a false negative, and then the other ones. Last term we got a true positive, this term a true negative, last term true positive, this term false negative. So those are the 4 arrangements of positives and negatives. So then I went through them case by case. How easy it is to believe that last term was a false positive and this term was a true negative. Which means last term we got those ridiculous results, but that was an error. And this term, we actually got the correct negative test result, which means that we thought there was a difference in the percentages, but they were actually fine. What do you think about that? So last term was, not you guys, last term that got deviance, we did it again 26 times. That's the point. That's the point. I've done it 26 times, and in those 26 times, it always came back with a positive test result. So what do you think? Does that mean that last term is most likely a false positive, statistically speaking?
Yeah.
Hell no! Because if last term was a false positive, chances are the term before that was 2, and the term before that, and the term before that. The chance of that happening is 0.05 to the 26th, which is so small. Well, and I said, well, it's essentially exactly the same p-value you always get from us, which is too small to believe. So in other words, numbers 1 and 2 about the false positives last term, I threw those both out because they're not statistically likely. So then I said, okay, last term probably was a true positive like the rest of them. How do I feel about this term's negative test result? Because what do we start calling foul towards the end of class? That it might have been a what? Oh good, an outlier. So what kind of negative? A false negative, which we don't talk about a lot in this class. You have an exam question that's devoted to it. The one question that ties off your quiz from last week, I think it was, is actually tied to the idea of a false negative or a true positive. So the idea is, let's talk about the false negativity possibility of the M&M. So we said everything's fine, maybe we're wrong. Now, I got into this a little bit. I got some software that allows you to do what's called power analysis. We talk all the time about confidence in this class. Confidence, confidence, confidence. So you have this 95% confidence. And when you go outside that 95% confidence, you got the tails, right? Usually that's 5%. Remember what that's called? It's the complement of confidence. It's okay if you don't. Do you remember what it's called? Significance. Yes! So these are often called tests of significance because you look for small p-values. Because a small p-value means you landed in that significant region, which means you got significant differences. Ha! What if you get a big p-value? Well, that's not statistically significant. On the null curve, which is this, you can't see it, it's red up here. You take a look when you come up, it's red. But there's always the other curve, yes, the other. It was so fun to see some independent software that drew 2 curves too. I love that, made me happy. So notice how the red curve for the M&Ms would have been here. The blue one would be the supposed research curve. Now there's always an issue when you do the supposed research curves. There's always a reason with that because you don't know exactly where they are. You know where the null curve is. M&Ms told us where the null curve was. They said this many orange, this many red, this many blue. The research curve, I had to pick where I thought it was. So I picked the smallest deviation I could from Mars, which means I didn't expect there to be all that much of a difference in what we got versus what they said we were going to get. Because honestly, the result that we got surprised me, so I said, okay, maybe it's not that different. So I put in the smallest possible difference I could, which then located the curve. Now the problem, and you probably can't see this from where you're sitting, but this beta area right here, that's unfortunately the chance of a false negative. You got alpha. We've used that letter before. That's the significance level. Alpha, 0.05. Beta is the other one. I've often asked you time and time again, what's the chance of a type 2 error? And then I say, don't answer that because you come back with,
we don't know.
you don't know because it depends on a parameter that you have to pick. So I picked a parameter, and I got a chance of a type 2 error, 75%. 75% chance of an error, type 2. How did I feel about that? Well, I felt awesome, not enough to write a letter about it. So I kept going. Whoops! That word, whoops. See that blue curve, blah, blah, blah? That's the false negative probability, which means of those 4 cases I had outlined here, the chance of a false negative is pretty damn good. Which means, yeah, you got a negative test result, but it's a pretty damn good chance that it was the wrong test result. Yeah? Is that okay? See how I'm getting at there? Now it's tricky. You guys will be doing a similar calculation in your exam. Not on a chi-square. It's too goofy. And I put, it's pretty easy to believe in a false negative when a second box from the same lot yielded a positive test result. And we've gotten positive test results dozens of times before, and I gave them the picture of the letters so they can see every one of these. Every single one of these letters is a positive test result. It's hard to believe they're all false positives. This is why, if you test positive for a disease or a drug test or a DUI, and you know you're clean, you test the second time. Because the chance of getting 2 false positives is exponentially 0. I mean, the chance of 1 false positive might be 5%, but the chance of 2 of them shrinks down below 1% really, really quickly. The chance of 26 false positives doesn't exist. Doesn't exist. What does this mean? It means, yep, we'll be testing your candies again. Feel free, as always, to send more our way, especially if they come from different manufacturing and distribution centers. I thought that was a clever twist on it. rather than making me buy them at Costco all the time, because maybe I'm getting them from the same center every time.
Are they sending you any at all?
The first time I got a $5 gift certificate. I've got nothing since, except the same form letter every term. At least I sent him letters back, I guess. And Jeffrey Wynn, if you're watching, Jeffrey, he actually customizes the form letter. Like sometimes the first line of the letter is, thank you for your inquiry regarding M&M's candies, and Jeffrey actually gets in there, thank you for your annual letter. And I send it back, I'm like, oh, it's actually triannual, but it's nice that you read it. Especially if they come with blah, 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 that way we get more percent. And as always, will be available at the address on the first page. Thank you for your time. As always, look forward to hearing from you. So if you guys don't mind, just go ahead and slap your John Hancocks and Jill Hancocks on there. At the break, we'll mail it off. And then you can visit me next fall, and well, you come by the office and see the next rejection letter hanging up next to it. But it was very interesting to me. Very, very fun results. First time it's ever happened historically, and pretty sure it's false negative, but whatever. How often do you experience a false negative where you're absolutely, almost positively certain that it is a false negative? Never. Like, that's what's so cool about that. If that had happened on the very first time I ever did the experiment, I doubt very much I'd still be doing the experiment. Because it's like, oh, they said it was going to happen, and it happened. Like, nothing to write home about, right? But it didn't happen for a decade, and then it did happen. Which makes me think one of two things. They fixed the machinery, magically, while the box was sealed. Or we got a false negative, which is worth talking about, as per that article you sent me a month ago, Di, about the lack of false negative research, or the true negative research, I guess. But the lack of negative test results in the research. There's a perfect example of one. And you guys made me happy because you're sitting there. You have no idea why I made such a big deal about it at first. You're like, he's getting all worked up about a big p-value and a small test statistic. Like, okay, freak. Usually it's the other way around. Yeah, usually it is. Because you don't have that wonderful 10 years worth of data coming at it. Wonderful. I know it's wonderful. Personal thing. So anyway, sign that if you don't mind. And that's that. What is a goodness of fit? We did a goodness of fit test. That's what that was last time. What is a goodness of fit test? Why is it called that? Why is it called goodness of fit? What are you fitting good? Well, please.
The data around the line.
Oh, what line?
The goodness of fit line.
Is it a line? In what way is it a line? Oh, you're thinking of a linear regression. Okay, so, okay, I like what you're saying, Veronica, but that's bivariate data. So Veronica's referring to your project, which you're going to email me before class starts on Thursday, yes? Right, correct. Thank you, John. So that's where you have a dependence in two measurements, in two connected data sets in two different measurements. So you've got, and it's not a pre-post, it's some particular point has an X value and a Y value. And you're trying to see if there's a predictable relationship between them. In my 105 class, we look at all kinds of these. We spent a lot of time actually in that class doing this. They let me go careening down a hill on my bike, and we plot my distance versus my time, and that's parabolic. And there's all, you guys are looking at some of those. But how's the goodness of fit different? I think you were getting at it right there. Go ahead.
The observed data versus the expected.
Nice. So you've got, and those, whoops, yeah, that's fine. Exactly. And what kind of variable is observed and expected? Like, for example, Mars came at us with these colors, correct? And in all their rejection letters, they always tell me the same thing. There should be this many orange, this many red. What are those this many's? Exactly, they're percentages. They're percentages. Thank you, Caitlin. So, with a goodness of fit test, you have an assumed percentage distribution. How many percentages? How many? M&M's we had 6. The iPod randomizer we had 10. So how many are we interested in for a goodness of fit? Define a lot. I love that answer. I heard a lot. I love that. Over, good, 3. Can I say 3 or more? Emily, thank you. Yes, 3 or more. Why 3 or more? Why not 2? Because with 2, excellent. When you only have 2 proportions to compare to each other, it's easy to tell which one's different. You subtract them, and if you get a positive number, the first one was bigger. If you get a negative number, the first one was smaller. And then you can measure the bigness or smallness of that on the Z-curve. It's perfectly fine. As soon as you have more than 2, that's the problem. As soon as you go above 2, you can subtract them. But then you're going to get a number and you have no idea which one's bigger than the other. Because you do 1 minus 2 minus 3, you get a negative number, but which one is the second one bigger than the third one or smaller than the first one? So it becomes a challenge to see which one. That's why goodness of fit is so wonderful. Because then you can, if you will, pair them off, and I'm using that in quotes because it's 6 or 10 or 30 or whatever you need. You can pair them off all at once and check the deviance all together. The only catch is that you have to use that new distribution. That's the only catch. You have to use that chi-square because the z won't work anymore. It doesn't have enough dimensions to work. Fair? Believable? Okay. So 3 or more goodness of fit issues. That's why you're going to need goodness of fit on your last exam for the American Heart Association test. Right? How many questions on the... I don't know if you got a chance to look at it yet. How many questions on the American Heart Association? 25, sorry. How many choices for each question? If you looked at the exam already. Oh, you haven't? I'll stop talking about it then. I'll stop talking. That's okay. I'll stop talking about it. Linda, go ahead.
You said that the project needs to be emailed to you?
Yes!
Okay.
It says that in the project somewhere. Okay. So anyway, that's the difference between regression, which is taking bivariate data, which means each data point has an X and a Y coordinate. Like for example, on that Facebook data, you've got a easiness score and a popularity score. So, you know, each randomly selected prof that I pulled has each of those.
Okay.
It's not a pre-post, it's just they both occur at the same time. And that's the difference because the M&Ms, you count the orange ones and there's this many. It's not that there's this many now and there were this many last term. I'm not doing that, it's just one single univariate data. And everything we're going to deal with today, and you know, I mean, everything's univariate except for that project. That's why I took that project and made it its own thing. It's different enough than everything we do in the class to kind of stand by itself. Plus, I hate the way your textbook does it. It's lame, totally lame. They don't use Excel at all, which is dumb. And they don't use technology at all, which is dumber. So good connection, in my opinion, Cool? So, the last question, and you might want to grab a template on this one. We'll slowly develop this into a quiz today. My last question is, yeah, if anybody need more quizzes, this is a beautiful one. Oh, yeah, right there. I was hoping to have a 4th data set. I was hoping that the rush order I put